Welcome to the Easy Access 1, Project J1P. Project J1P, to build a multi-threaded Java-based TCP socket forwarding program. Chapter 1. We're going to create a loader and control class. After that, we will create the port and IP assignment variables. After that, we will create our multi-threaded individual stream classes that we called conduits. I'm calling them conduits for this project. And then we'll look at memory management. It'll be based on Java 1.8. We have a client connect to our conduit object. Actually connect to the conduit controller object, which will spawn a conduit object and pass the socket. And our conduit will connect to our third-party server. Our server will reconnect to our other conduit, our multi-threading, and the returning socket will be created and we will connect backwards to the client. Simple enough. This is going to be the simplest Java tutorial in the series. So let's get going. All right, we're in Eclipse. I'm going to move really fast through this. New Java project called Conduit Project. I'm going to use JRE 1.8. In my Conduit project, I'm going to make a new package called Conduit Package. I'm going to make a new class called Loader. I use the Loader class exclusively. I do this so that I can port my programs to Java, Enterprise, or wherever I'm going with this, so that I can modularly export the program away from my public static void main. String args, multi-dimensional string array, and then I'm going to make a new class called Conduit Controller. And in my public static void main, I'm going to make a conduit C-O-N-D-U-I-T-C-O-N capital C-O-N-T-R-O-L-E-R conduit controller CC equals new conduit controller C-O-N-D-U-I-T controller equals conduit controller. Case sensitivity issue. Conduit controller. It's going to let me rename, or let's just delete it. New class. C-O-N-D-U-I. Java's case sensitive, guys. Remember that. C-O-N-D-U-I-T C-O-N-T-R-O-L-E-R. Conduit controller. Should now pass the compiler. Conduit controller is going to be our parent. All right. Part of conduit package. Okay. If anybody's watched any of my tutorials before, I like to use a private string called module. I'll assign the module variable name so that I know where I am when I have an exception. I'm going to create an integer called the listening port. I'm going to set that to 3306. I'm going to set a destination IP address. This is the server that I'll be forwarding requests to. Okay. I'll have public class conduit controller. I'm going to start my constructor. Be a method, actually. For all you guys who watch my tutorials, I like to label my squirrely brackets here. That means end method, end class. This way I don't end up with a project that doesn't compile if I'm in Notepad or if I'm in a telnet session in Vi and I can't figure out where my brackets are if I'm outside of Eclipse. Okay, let's go flying through here. We're going to start a try loop or try block. And let's get our catch set up. Okay, try catch blocks, basic Java. Our exception will be printed out. And we're going to have one module, and this is where the module is going to be displayed in case of a problem. Module equals equals main conduit controller. Okay, this is a very small project, so I probably could have got away without the module, but I keep it because that's how I write things. Okay, the simplest of all starts, server socket. Okay, we're creating a new server socket listen port. Eclipse is going to cry, so we'll add import Java net server socket, and let's just do star. Who knows what else I'll pull in here. All right, we're going to start a loop. This is going to be a multi-threaded server, and it's going to run ad infinitum. So we're going to have a while true. Here you could actually use a variable name if you wanted to control this somehow from another object with perhaps a callback. You could create a variable, a boolean, switch here, and set that true or false. If you wanted to shut the server down programmatically, that's up to you. Okay. Okay. We're going to create a socket object from the server socket, and I'll call this the in socket. Okay. I'm going to go up here and create a string called the connection ID. So I have some track. I keep some sort of track of how many connections are active right now or whatever. Connection ID. All right. Super simple here. I'm going to drop down to my console logger, that client, and if I start at 0, I'll end up with connection 1. So client concatenate ++ connection ID, which means I'll add 1 before I display connection ID. So it'll say connection 1 is connected for the first connected. The minute someone connects, I've decided for this project that I am going to set up my outgoing socket. My outgoing socket will go to the destination IP address, and it will go out on the listening port, and we've defined them here up top. Okay. All right. Let's create our conduit. Our conduit, new conduit, which is not going to pass the compiler because I haven't created that class yet. I'm going to create the conduit class. We should now pass the compiler. All right, conduit class is going to implement runnable so that we can thread it. Public class conduit must be, yeah, and it's going to cry until I put a public void. Okay, got that. Super simple there. Now we're going to thread our first object. I'm going to create a thread called the incoming data thread, and I'm going to load the object conduit. I'm going to pair it up. That's going to be so simple. Okay, now let's do some work in conduit. In order for conduit to work, it's going to need to know about two things. Each conduit's going to need two things, an incoming and outgoing. So the incoming for the conduit thread is going to be an in socket. So first I want to know what direction we're going. See. Oops, sorry guys. Okay, so I'm going to have a string called direction. Now the reason I'm doing this direction is that I'm going to spawn two conduits, one for the incoming, one for the outgoing. I'm going to bridge the top and bottom that you saw there in the PowerPoint. So in order to do that, I either have to write two classes, okay, or I have to write two separate parts of one class, or, and ready for this, I'm going to write one class that's going to be a threaded, multi-threaded class, and inside the class I'm going to detect where almost a configuration parameter. So the direction is going to tell me whether it's the in or out. So is this the one that goes to the left or to the right in that PowerPoint that you saw earlier? Okay. So for the conduit to work, it's going to need an incoming and outgoing socket, or a reference to them. and then an identifier, which I may or may not use later. All right, and let's just put our basic conduit constructor in here just in case anyone calls it. I don't think I will, but I pop it in there. Okay, so let's get our try and catch loops going. Try. And a catch. Okay, and don't forget your public string module. Okay, and module equals conduit.run. That's where I am. Okay, easy enough. And over here, I'll add that. So we have some error tracking. Okay. All right. So let's start. We're going to need an input stream. I'll call it A. Okay. And we're working with two different sockets, the incoming socket and the outgoing socket. And each socket's going to have an input and an output stream. So input stream, I'm going to load the Java IO input stream. Socket in socket. And let's get everybody happy here. All right. So input stream A is going to be our input socket.get input stream. And input stream B, or output stream B, is going to be equal to our out socket.get the output stream. Okay, so we're going to assume that this is the incoming direction. This is the one coming from the conduit object that we're going to create that handles information coming from the client and going out to the server, third-party server. But we have to make an allocation for what to do if it's not. All right. So if it's not, if it's the direction actually equals out, then I need to reverse that formula. So the reverse of A equaling input in socket.get input stream is A will equal out socket.get input stream. Okay, so this will reverse the flow. And I'll do the B to do the same thing. All right. Now you'll see why I'm doing this when we get back into the control class. So now I'm going to write a generic piece of code that will take the information from the input stream and write it to the output stream. This is going to be the simplest thing you've ever seen. I'm going to make a new byte called buffer and raise that to the 13th power. All right. You can make a bigger byte buffer if you want. I found that 8,000 bytes of data is usually a pretty good number. You're welcome to take that up to any sort of limit you want. Okay. Integer and the number of bytes read. Okay. Well, the number of bytes read is equal to A, and I'm going to load the buffer with the number of bytes that were available. If that's not equal to -1, then we're going to enter our while loop. Okay. Let me go through that again. An integer will be created, will be addressed, and it will be loaded with a number. And this number will equal the total number of bytes that were contained in the buffer as we read the bytes from A, which is our, depending on how we're set up here, our input stream. Okay, so that's most likely going to be 1 byte, but it could be any number of bytes up to 8,000 at this point in time before it throws an error. All right, and very simply, we're going to take that buffer and we're going to write that to the output stream. Okay, that's my loop. And let me think, a write's going to need to be flushed. So Let me just flush it. Okay. All right. Okay. Now that will continue on. If we get to the point where we were not in the while loop, then we know that this equation here is no longer equal to -1. That means that the connection's been terminated. So I'm going to write the standard out that a connection ID has exited from this loop. And when that happens, I want to close. If either the server or the client has terminated the connection, I want this whole shebang to shut down. All right. So I'm going to close the input socket, insocket.close, and that's very likely to throw an exception in a multi-threaded application. And we're on the way out, so I'm perfectly fine with that being a catch exception. I just want that to happen, whether or not it's closed or not. I want the instruction close to happen. Then I want the out socket to close, and an exception can happen, and I'll ignore it. All right. And now we've made it down to our end catch. And this is the end of run. And this is the end class. All right. Label your curly brackets, guys. You will pay in the end if you don't do it. All right. This is super simple. Pass the compiler. Now let's finish up our conduit threading class. You remember those objects that we created called outSocket? I'm going to pass off these input and output sockets, these two sockets. I'm going to pass them off using the thread into the CT object. And there's the input in socket. I'm going to assign my direction. I'm going to assign an identification. And I'm going to start that thread. Okay, that will take care of one of the two threads that I'm going to run for this project. So let me do the second thread. Now you could do these in an array. You could create some sort of little thread factory, but since we really only need two, I'll just make a CT2. Outgoing data thread equals CT2. CT2.outSocket. I'll assign the out and in sockets here. The direction, this one goes out. And I could really actually skip this line here, direction in, because that's going to be assumed, but I'll leave it in here so that you guys can make sense of this most simplistic code. And I'm going to start the thread. Okay, so very briefly, let's do a high-level overview. We're going to create a conduit package, and the conduit package is going to have the conduit controller. Conduit controller has been called by the loader class. We have a module string, the listening port, the destination IP address, and the connection ID. All right. My module in this case is my main conduit controller. Here's the system will pause here, waiting for a connect on the appropriate port, which is 3306. As soon as there's a connection, we'll go into an infinite loop, creating a socket, and we will create the socket called inSocket from the server socket. Do some output to my local console. I'll create an output socket where I'll connect to the outgoing IP address, okay, on the listening port. See, I'm using the listening port. Now you don't have to do this. Actually, let's just call this port, okay, because it's not really a listen port. It's not really a destination port. We'll just call it port. Now what you could do is split this, and you could listen on a different port than you're forwarding to, but that's, you know, totally up to you guys. Say you want to forward on port 11111 or something like that. Okay. Then we're going to create a new thread socket, a new conduit object. We're going to load it into the thread. We will assign the variables, which is going to be our output, input socket, out and in socket. The direction, basically who it's going to talk to and who it listens to. An identification, and start it. And then I'll start another socket thread, another conduit thread, and it will work in reverse because of the keyword out in the direction. and we'll load the socket objects, and we'll start it. Let's go through our conduit class, module run. Okay, we're going to assume the keyword in which case our input stream A is going to be equal to our input socket.get input stream. B will be out socket.get output stream. And then if this is a reverse direction, I'll flip them so that we'll create the socket that goes the other way. Now, this is the only part that's a little difficult about this. You need to understand that this code will run twice. This run method will run twice, and they won't have anything to do with each other because I haven't encoded any callbacks. So these two sockets don't know anything about each other. Well, they do share the socket objects, and if one closes, it'll throw the exception in the other one, but that's okay for now. I'm going to create a buffer object. This is like a bucket, and the buffer will be equal to about 8,000 characters, 8,000 bytes. I'm going to create a read object, an integer, to hold the number of bytes that have been pulled or that were available. We're going to pull information out of the input stream and write it to the output stream. And then we'll close. Okay? Simple enough. We will run. Nope, I got a problem already. Okay. Args. That was a good, nice mistake to have. Makes me look like a genius here. Good night. Didn't like that. Okay, hit save a couple times and I'm good to go. Alright, I ran the project. The loader called the conduit controller. And I'll bring up a copy of an old SQL control program I use sometime. Here I've created a connection object to connect to my local host on port 3306. Alright, now I connected. Alright, looking at some data here. Alright, here we go. Tables. So I'm connected to what appears to be the local host, even though I'm not running MySQL on my local host. Alright guys, disconnect. And you can see how the connection, there was connections, and I was closing sockets. And you can hide those exceptions if you want, or you can change the way your code works to not use exceptions on socket closing. Alright, super simple. I appreciate it. This is our easiest tutorial we have, where we create a multi-threaded connection object, conduit, that opens up ports to become available through IP addresses that may only be available through certain networks, for instance on a host bridge or some sort of router or some sort of a machine that has dual IP addresses. It's a way to get your data through if you need to. And there's lots of commercial programs out there that do this, but this one would be yours, and you can write it in under 10 minutes using Java. So let's review. We created a conduit object. The client connected to the conduit object. The conduit object connects to the third-party server. In this case, we used MySQL on 3306. You could pick any IP address. You could pick any port as long as you had the appropriate client connecting. Then they connected back through the second conduit object that we created, and that second conduit object relays information back to the client. If you'll notice, we implemented runnable, and we extended thread, and no, we didn't extend thread. We created thread objects and we extended runnable. And both these conduits are running in a multi-threaded environment. They're running independently of each other, more or less. And that should have been a pretty CPU-friendly implementation. Chapter 2 will add a logging object so that we could do a binary log on information, and I'll show you how to do a text log and a binary log. Thanks a lot. Make sure you subscribe and have a great day.